Well, you've made it to week 10 of MAT 205. This week is a testing week. So just some information about the test. Just keep in mind, you still have to use that Respondus lockdown browser. Don't forget your photo ID. You can bring a page of notes, handwritten notes or typed notes, however you like it. Make sure you're not using your phone, another computer, or other help aids to help you, like, ChatGPT or AI or Chegg. All that is considered academic dishonesty. So you don't want to use anything outside of your brain and your notes. You've got 2 hours and 30 minutes to complete the test. You've got 15 questions. And don't forget, when you start to take the test, you can't close it. You got to take it in one sitting. And then after the deadline for the test has passed, you're welcome to go in and review your test submission. So I'm going to look at 5 problems that could be tricky and could be troublesome. And they perhaps may or may not appear on test 2, but we want to be prepared. Okay, so I've started to sketch this one out. This is one of the trickier ones. It says, suppose Z follows the standard normal distribution, use the calculator provided or this table to determine the value of C so that the following is true. The probability falls in between a Z-score of negative 0.67 and some unknown Z-score, and that area has to be equal to 0.7205. I rewrote it kind of here. The probability needs to fall between a Z-score of negative 0.67 and some unknown Z-score. Right? This is going to be the question mark. And it has to equal this chunks, 0.7205, which is, if we know the whole thing is 100%, 72%, it's going to be a large chunk. So what we know is that 100% of the area is under the curve. That's in percentage form, or if you're looking at decimal form, which they're working with, we know that the area under the curve is equal to 1. Okay, so I started to sketch this out. I know that 0.07 or 0.67 negative Z-score has to be to the left. So I kind of put that there. And then I kind of sketched myself out a little, I guess an orange kind of segment, and I put a question mark here. We're trying to figure out what Z-score that is. Probably the Z-score is going to be positive, because if it's 72% and we want to be in between negative 0.67 and this unknown Z-score, then we know that 72% is going to take up a large chunk of that. So you might be wondering, how did I get the 0.2514? Well, I went to my table and I found a Z of negative 0.67. So I went and found negative 0.67. Let's see where that was on here. Right here. Negative 0.67. And it came out to be an area of 0.2578. Or excuse me, 0.2514. So many numbers here. Yep, negative 0.67 goes with 0.2514. So I wrote that on there, because if they're going to give me a piece of information, a Z-score, I'm going to go to my table and I'm going to get that chunk, that piece. That's 25% of the whole 100%. Now, the goal is to figure out what the Z-score is here. And so we don't know what that Z-score is, but we do know that it needs to cover at least 0.7205 of this area under the curve. And we also know we have 0.2514. So what do you think we can do with 0.2514 and 0.7205? Hopefully you're thinking about it. We can add them together. So hopefully you're thinking about addition. So we'll add them. So we're going to add that chunk there. We're going to add this chunk here. Once we get that total area, we can figure out what's the Z-score that goes right there. So what's that? A 9, a 1, a 7, 0.9719. Okay, that is going to be the area. And now the key is, let's go find the Z-score that corresponds to 0.9719. So 0.9719, I think I see it already. That's lucky. 0.9719 corresponds to a Z-score of 1.91. Okay, yay. So 1.91 is going to be our Z-score. That is that piece right there, that missing link, that unknown value. But we had to use what they gave us. They gave us a chunk of the area. They gave us a Z-score. We used the table to find the area underneath there. from, from this tail to here. Then we were able to take that value, that area plus this area, pull it all together so we could figure out what this z-score is right here. And so when we added the area together, we got 0.9719. And then that corresponds to a z-score of 1.91. So that's perfect. So hopefully you're feeling a little better about these types of problems. They definitely just take some practice. Okay, here's another one that may seem not so tricky, but it tends to throw people off. So let's make sure it doesn't get you. Comparing the measures of center and variation. We have 4 teams, and it looks like it gives the ranges of ages and the average age of these people, I guess, on these teams. Maybe they're soccer teams. Okay, 2 questions. Based on the information above, which team has the youngest member on average? So we're looking for the smallest mean. And which one of these teams has the smallest mean? Well, hopefully you're seeing 49, 43, 48, 52. 43 is the youngest age on average, so team B is going to be our selection there. All right, now based on the information above, which team's age has the most variability? So I want you to pause the video if you haven't already and give an answer to this. So if you're back, the largest range is what you're looking for. And we got 20, 16, 13, and 14. So team A is the winner chicken dinner. That has the most variability, okay? Has the largest spread of numbers in it because 20 is the biggest number. Okay. All right, here's another one that can sometimes be tricky. They might give you some information in a table and ask you to find the weighted mean. Okay, the birth weights to the nearest pound of a sample of 38 newborn babies at a certain hospital are given in the following table, along with the number of babies born at each birth weight. Okay, so it looks like there's 38 newborns. If we add 4 plus 11, 15, plus 14 plus 9, indeed, that is 38. So always check your chart, make sure they haven't tried to do any trickery there. Okay, so 4 babies clocked in at 5 pounds each. So you're going to multiply 4 times 5 and get 20. 11 babies weighed 6 pounds. 11 times 6 is 66. 14 babies weighed 7 pounds each. So that's when you multiply them 98. I'm just going to put the sign of multiplication here. And 9 times 8 on planet Earth is usually 72. Okay, so when you're finding the average, you have to take all of your data, right? And you need to add them up and then divide by the number of numbers that you're dealing with. Well, we've got 20 plus 66 plus 98 plus 72 divided by 38. And let's see what that gives us for average weight of these babies. So make sure to pause the video. 256. 6.736. Okay, so if we want to go to 1 decimal place, it's going to be 6.7 pounds is the average baby weight. That's somewhere like right in here. Okay. All right, so hopefully that helps when you end up with weighted mean in a tabular form, like in a table. You don't necessarily have to do it this way. You could write out the number 5 4 times, right? You could do 5, 5, 5, 5 pounds. You could write out 6 pounds 11 times, you could do this and then add them all up and divide by 38, but that is can be time consuming and you might get lost in the sauce writing out 11 6s and 14 7s and 8 9s. So the shortcut way is the way I just showed you, was just to multiply across. But any way you want to skin that cat, totally fine. Okay. Sample standard deviation. Yep, we have that one and one more. All right, we got this. So the monthly salaries of a sample of 5 sales representatives are as follows. Find the standard deviation of the sample. Okay, so make sure when they say sample, you know which formula to use. So let's see if I can write down the formula correctly. Standard deviation from a sample is going to be the sum of x minus x bar squared divided by n minus 1. So remember, there's a little bit of a different formula when you're working with population, but because they're using sample, we're going to use this formula right here. So the first thing we need to do is find the mean of all of these salaries, subtract the mean from each one of those pieces of data. Once you get your difference, you square the differences to standardize them, add them all up. That's what the Greek letter E says, to sum it up. Divide them by the number of pieces of data minus 1, and at the bitter end, take the square root. So let's go for it. I'm going to write these numbers vertically. The first thing I'm going to do is figure out the average. All right, so the average is 10. That's easy enough. So X bar equals 10. That's this right here. Now we're going to take that. It says take that average away from each one of these pieces of data. So we're going to do that. So 7 minus 10, we know is -3. 1, 3, -2, 1. And then it wants you to square them. See, this formula says after you find the differences between your data value and the average, once you get that, square it. So -3 times -3 is 9, 1 times 1 is 1, 3 times 3 is 9, -2 times -2 is 4, 1 times 1 is 1. Now we're ready to sum these up. So we're going to add these up. So here we are summing up 9 plus 1 plus 9 plus 4 plus 1. And we're going to divide it by n minus 1. Okay, let's figure out what these are. 9 plus 1 plus 9 plus 4 plus 1, 24. All right. So to find the standard deviation, we got to take 24 divided by n minus 1. Well, n was equal to 5 pieces of data. So 5 minus 1 is 4, which makes 24 divided by 6, which we don't even need a calculator for that. We just come up with the square root of 6. Okay, but they want us to give an answer in decimal places, so we're going to take the square root of 6. So you've probably figured out on your calculator how to take a square root. On mine, I just do it like that. 2.449. All right, and since they want you to go to 2 decimal places, I'm going to take and look at that 9. The 9 is going to tell the 4 to go up, and 2.45 is our standard deviation of the sample of 5 sales representative salaries. That's a lot of S's. Salaries of 5 sales representatives standard deviation. It's S's gone wild. Okay, one last problem that tends to kind of throw people off in the past. So I've been teaching this class for, I think, 3 years now, every semester, spring, summer, fall. So I kind of have an idea of pitfalls and problem areas. So hopefully you don't encounter these on the test, or if you do, you will know how to tackle these. Last problem. So it looks like a little innocent pie chart. The pie chart below shows how the annual budget for a certain company is divided by department. If the amount budgeted for sales, engineering, and media combined is 40 million, what's the total annual budget? So sales, engineering, and media. So media, engineering, and sales. So this piece right here, this chunklet of the pie, is responsible for 40 million. So what's the total annual budget? Well, we don't know what that is. But we do know that the media is equal to 7%, engineering is equal to 18%, and sales is equal to 15% of their budget from this company. Okay, let's add those up. So we got 7 plus 18 plus 15. So we get 40. All right, so we got 40% is what we know is the total of media, engineering, and sales. So we're going to convert that to a decimal. So we're going to get 0.40, and we're going to multiply that times the annual budget, which we don't know what the annual budget is. So in algebra or in math, when you don't know what something is, you usually call it X. But we know that 40% of that total budget is equal to 40 million. Excuse me, 40 million. Okay, so you might see it more like this in algebra. All right, you may not see that little multiplication sign in between. When you have a decimal snuggled up next to a letter, it just indicates multiplication. Sometimes people might write it like that. Okay, how do you get rid of multiplication? Because the goal is to find out what X is, but we have this pesky 0.40 multiplying to X. So The opposite, of course, as you know, and probably remember from Algebra 1, Algebra 2 days, is divide. Because 0.40 divided by 0.40 is just 1x. And then we got to take 40 million and divide it by 0.40. Oh, Lord, that's a large budget. Okay, so that's a 1, 8 zeros. Whew. This company's got a giant budget here. All right. So that is 100 million is the total annual budget. And you can check yourself. You could take 100 million, multiply that by 0.40, and that's going to give you that 40 million. So we know we're on the right track here. Or 40 million is 40% of 100 million. Okay, that's it for the problem area. Hopefully you take that practice test many times until you feel really good about those 25 problems, and then tackle the test, which has got 15 problems in it. I wish you well. Good luck. See you next time.